ammonium cations act as acids as long as there is at least one hydrogen directly bonded to the nitrogen. Sometimes quaternary ammonium cations can form when there are 4 bonds to carbon-containing groups. So that's why we have to specify at least one hydrogen has to be directly bonded to that nitrogen. So we have 3 examples of quaternary ammonium cations, primary, secondary, and tertiary amines, and let's look at how they react with hydroxide. So our first example, we have ethyl ammonium reacting with hydroxide, and the definition of an acid is it is a proton donor. So the ethyl ammonium donates a proton to hydroxide to form the amine, ethylamine, as well as water. In our second example, we have diethylammonium. It donates a proton to hydroxide to form water, and then once that proton leaves the quaternary cation, it forms the original amine, diethylamine. And then triethylammonium donates a proton to hydroxide to form the amine, triethylamine, as well as water. So we notice that each of these equations has a double arrow, and in an acid-base equilibrium, the side of the reaction that is favored is the side that has the weaker acid and base. So for each of these examples, it is the right side that is going to be favored because an amine is a weaker base than hydroxide, and water is a weaker acid than a corresponding or quaternary ammonium cation. So one of the things we want to notice that is a pattern for each of these is each quaternary ammonium cation donates one proton to the base to regenerate the amine.